7, 6, 5, 4, 3, 2, 1.
In today's day and age, space travel hasn't been more relevant than it is right now. Research and development are undertaken to improve space travel each and every day. This is done in the hope of someday being able to colonize another planet. In this experiment, the group of students decided to look at one of the most crucial parts of a rocket, the nose cone.
Here at JMSS, with the help of the school lab techs and the High Powered Rockets team, our team was able to test the friction of rockets using fluid dynamics. Fluid dynamics is how objects channel in water or fluids. Using the water column to test aerodynamics of the nose cones, we were able to single out the fastest nose cone shape.
These nose cone shapes include elliptical, ogive, parabola, power series, cone, von Karman, and a blunt-shaped nose cone. The blunt nose cone is used as a comparison to determine the least aerodynamic model. These shapes were then dropped into a water column filled with water, and with the help of a physics modeling app, Tracker, we were able to track the velocity of the rockets and map out the most aerodynamic nose cones using the graphing system.
The results show that the elliptical was the fastest nose cone. This had a streamlined shape and is used on many fighter jets such as the MiG-29, F-15 and the F-22. It allowed for the water to flow around the nose cone quickly and stayed stable throughout its descent into the water column. It is also shaped most like a water droplet, which is one of the most aerodynamic shapes in nature, as water always takes the path of least resistance. The slowest was the cone, the shape that many would default to when drawing a rocket. At its core, it is still aerodynamic, but its simplicity and disregard for nature's flow of movement made it lose out to the other, more advanced designs.
Even the best experiments have mistakes, and with our experiment, the blunt had more mass as compared to the other nose cones. This caused the blunt to have the higher velocity in water due to the greater mass, and the blunt ended up being the third fastest nose cone, when in reality it should have been lost. Due to the water column and the rockets being powered by gravity, the real world would have rockets oppose gravity, and so the weights would need to be kept at a minimum. Due to this, the experiment did not have perfect accuracy, but the elliptical can be trusted as the fastest nose cone.